Hello everyone, welcome to this video. In this video, we are going to learn about the relationship between the concentration terms normality and molarity. In our previous discussion, we have defined the term molarity as molarity is equal to number of moles of solute per unit volume. This volume is expressed in liters. Similarly, normality is defined as number of equivalents of solute per unit volume. Again, the unit of volume is in liters. So, if we somehow relate the number of moles N to number of equivalents NEQ, then we may derive the relationship between molarity and normality. So with this motivation, let us move ahead and see if we can find out any relationship between number of moles and number of equivalents. Number of equivalents is given by given mass of the solute divided by its equivalent mass. Let us represent it as m given upon m equivalent. Now, the equivalent mass is given by molar mass of that particular solute divided by its n factor. For example, if the solute is acid, then n factor will be its basicity. So let us represent it as m molar upon nf. Then we can substitute the value of m equivalent into the above equation. So n equivalent will be equal to m given upon m molar upon nf. On rearranging this equation, we can take m given upon m molar as one quantity and we will have 1 upon nf in the denominator. Now, given mass upon molar mass is nothing but it is equal to number of moles, and hence number of equivalents can be written as n times nf, isn't it? And here we have find out the relationship between equivalent, number of equivalent and number of moles. Now all we have to do is substitute this relationship into the formula of normality. So normality will be equal to n into nf divided by volume. Now we will club number of moles upon volume in one term, which will become the molarity as per the definition. So normality is equal to molarity times n factor. This n factor will depend upon the type of compound that we are using. Let us see an example to understand and appreciate the relationship between normality and molarity. We have to calculate the amount of H plus ion produced from 200 milliliter of a 0.1 normal H2SO4 solution. By following the definition of normality, we can say that 1 liter of this solution 0.1 normal H2SO4 will give us 0.1 moles of H plus ions. This is because normality gives us the number of equivalents present in a given volume of a solution. If we put the value of this volume as 1 liter, then number of equivalent will be equal to normality. Now, as per the definition of equivalent, one equivalent of an acid corresponds to the mass of acid, which will furnish 1 mole of H plus ion. Since in this solution we have 0.1 equivalent of acid, it will give us 0.1 mole of H plus ion. Okay, so we have 0.1 mole of H plus ion. Now we have to calculate the H plus ion found in 200 milliliter of the solution. This we have done for 1 liter. 1 liter will give us 0.1 moles. So we have to calculate for 200 milliliter. Since we have divided the volume by 5, we will divide the moles by 5 as well. So the number of moles of H plus will be 0.1 divided by 5, which will be equal to 0.02 moles of H plus ions. We have arrived at this relation, at this concentration, by following the definition of normality. Now let us see the mathematical approach and if it will also lead us to the same conclusion. We just derived the relationship as normality is equal to n factor times molarity. Molarity can be written as normality divided by n factor. Putting the value of normality and n factor as per the question, we can calculate the molarity of solution as 0.05 molar. So, saying 200 milliliter of 0.1 normal H2SO4 solution is same as saying 200 milliliter of 0.05 molar H2SO4 solution. Okay, now we have the molarity of the solution 0.05, we have the volume of the solution 200 milliliter. So we can calculate the number of moles of the solute as molarity times volume, 0.05 times 0.2. We have converted the volume into liters. Therefore, number of moles of H2SO4 is 0.01 moles. Now, the basicity of H2SO4 solution or H2SO4 acid is 2. Therefore, the concentration of H plus ion will be 2 times the number of moles of H2SO4. So here 2 is the basicity of the acid. Okay, and finally we conclude that number of moles of H plus ion will be 0.02 moles. So in our first approach, we just followed what definition says to us. In our second approach, we followed where mathematics will take us. We should have a good understanding of both the approaches so that we can really master the numerical problems. Thank you so much for watching, and in the upcoming video we will be concentrating on problem solving on concentration terms such as molarity, molality or normality. Okay, so see you in the next video. Thank you once again.